In this video, we're going to discuss the neoclassical synthesis. It's kind of a combination of, it's a compromise between a Keynesian model that we've been playing around with and a classical thinking in terms of macroeconomics. Okay, so it begins with what's called the long run aggregate supply curve, or LRAS. In the macroeconomy, we combine all production of all firms into one macroeconomic production function. And generally speaking, as the labor force size increases, which is L, and physical capital increases, K, and land and natural resources, R, and technology and entrepreneurial talent increase, which is Z, as those things generally rise, output of the economy as measured by GDP generally rises. Now, in the long run, all of these variables are flexible. They can be increased or decreased. For example, labor force can increase over the long run if our border walls are taken down and passports are eliminated. That would allow people to freely enter the country or leave the country. People are generally attracted to countries that have well-established freedoms, like freedom to speak as you wish, freedom to express your opinions, freedom to pursue your passions. Adam Smith might call them self-interest. Low corruption. So countries with low corruption and free speech and property rights generally attract people from other nations. So the labor force can increase due to migration from other nations. It could decrease because maybe the government becomes corrupt and people are fleeing it. The labor force could increase if, for some reason, people start having more babies, and over time, those babies turn into young workers. Physical capital, on the other hand, are things like factories, railroads, Wi-Fi infrastructure, optical cable, railroads, roads, etc. In the short run, that stuff is kind of fixed. You can't really change it. But in the long run, free societies, as we learned in our PPF lectures, free societies with strong property rights see their PPFs push outward more so than countries that are more heavily regulated, managed, or owned by government. So in the short run, physical capital is kind of fixed, but it can be very flexible and generally grows faster the more freedom and stronger the property rights of a particular nation. Land and natural resources are similar to capital, but the difference is there's only so much in the ground. There's only so much land, and there's only so much in the ground. So technology can increase our natural resources to some degree. Like fracking has made it possible for the United States to be an exporter of crude oil, of gasoline. Before fracking, that wasn't possible. So with fracking, it's made it possible for us to ramp up our production of gasoline. So it's more constrained than capital, but technology could get to the point where we could be flying space missions from the United States to Saturn and harvesting helium-3 out of Saturn's atmosphere. And helium-3 is very limited on the Earth, but not so much on the Moon, and definitely not on Saturn. So technology can allow us to expand our resources in a substantial way. Then we got technology and entrepreneurial talent, which is Z. This is kind of like know-how and risk taking. If people are more likely to take on risk, if they're less risk averse, they're willing to open up businesses and play that gamble. There's the potential for growth is quite a bit higher than in countries where that behavior is a little more restrained. Also, as we learn more about our world, about our universe, about our solar system, our productive capacities increase. Generally, in the short run, K, R, and Z are fixed. You can't build Rome in a day, right? Rome wasn't built in a day. It took a long time for Rome to construct the Colosseum, for example, right? But the thing about labor is, if you're talking about number of laborers in the economy, not all laborers are employed. Really, the only way, in a neoclassical sense, the only way to really ramp up production in the short run is by adding more workers to your production lines. And we'll get into that a little bit more later. So we're going to assume a very simple long-run production function. Now, this is a long-run production function because remember, technology and entrepreneurial talent is kind of fixed in the short run, but not in the long run. Capital is fixed in the short run, but not over the long run. Resources are fixed in the short run, but not over the long run. And then the size of the labor force is somewhat inflexible in the short run, but is most definitely adjustable over the long run. So because there's no numbers plugged into this, we call this the long run production function. Now, suppose in the short run that resources value $0.4 trillion in total for land, oil, coal, and natural gas in a given economy. Suppose the value of physical capital like machines, roads, and networks is $2.5 trillion. And then suppose this particular economy, with regard to all the knowledge that's available in the universe, this particular economy, the people have acquired 1.5% of that knowledge. So when we plug these numbers, which are fixed in the short run, into our production function, the only thing that is adjustable is the number of laborers. So in this context, this is the number of laborers. And in the long run, we call this the labor force. So in the long run, we call it L labor force. In the short run, it's the number of laborers that we have working. And the number of laborers is going to be generally less than the size of the labor force because every economy has unemployment. Now, when we do arithmetic, the 0.4 times 2.5, well, that's equal to 1. And the square root of 1 is 1, so our short-run production function simplifies to 1.25 times the square root of L. Okay? Now we're going to graph it. Now, unemployment, the level of unemployment is capital UN. It is equal to the frictional unemployment that's out there and the structural unemployment. We've talked about this in the production possibility frontier model of our macroeconomy. Now, natural unemployment is productive, right? And if you think about it, it's productive because people may not like living in, say, Florida because of humidity and the risk of hurricanes. So they might move to Utah to escape the humidity and escape the hurricanes. If they stayed in Florida, they might be miserable and they're not going to be very productive. If they decide to move to Utah, once they find that job in Utah, perhaps they're going to be happier because they enjoy the amenities of Utah much more than they enjoy the amenities of Florida, right? And it can go both ways. Maybe people in Utah are tired of dry, hot climates. Their skin cracks, and they decide to move to a more humid climate, say Florida. They're unhappy in Utah, they're not as productive. They move to Florida and maybe they like the humidity and they're more productive. So, or maybe the unemployment comes from automation. If you lose your job because the factory's been automated, a robot's doing your work. Maybe a robot's doing the work of 10 people. Robots don't take any time off. Robots work 3 shifts a day. They don't get, they don't have kids. There's no slowdown between shifts where people chat about their kid hitting a home run in last night's baseball game. So if you're replaced by a robot, that robot is doing the labor of 10 people, right? What does that unemployed person do? Maybe that unemployed person goes to truck driving school and becomes a truck driver, which increases the productivity because one, his or her labor is being done by a robot. Two, maybe there's a shortage of truck drivers. They go to truck driving school and now they are filling a slot that was previously empty. So whether the unemployment is structural or frictional, that is a productive source of unemployment. And then L in the short run is remember the L in the short run is the effective number of laborers in the economy. What that means is the number of laborers is the number of people who are employed plus the natural level of unemployment. Of course, this is productive, right? The more employees we have, the more firms can produce, the more GDP there is. And then we went through the discussion on why natural unemployment is productive, right? So this is what L is defined to be in the short run. It's the effective number of laborers in the economy. That's what I call it, the effective number of laborers in the economy. Okay, down here we're assuming that natural unemployment is 9 million, right? And then we're assuming that the employment level initially starts out at 41 million. So the number of laborers, you add the two together, is 50. You plug this effective number of laborers in the production function, and you get 8.839. Now, 50 is close to 49, and the square root of 49 is 7, and 7 times 1.25 is just under 8.839. So this number makes sense, right? We could calculate this number in Desmos.com. I'll do it right here. Okay, so we have 1.25 times the square root of 50, right? And you can see that the GDP would be 8.839, right? Which is what we got right there. Now we're going to plot this point in this graph. Okay, so the first point is right here. 50 million people are either employed or they're naturally unemployed. They're frictionally unemployed or they're structurally unemployed. And that height is at 8.839. Okay, the next dot is an employment level of 91 million. 91 million plus 9 is 100. We plug the 100 into the square root up here, and we get 10. And 10 times 1.25 is 12.5. So the production function goes from 0, actually it goes from 9, right? It actually goes from about 9 here. But we'll just assume it goes through the 0.0. So GDP from a 0 level of effective number of laborers, it jumps quite a bit when we add 50 million effective laborers. When we add 50 more, it doesn't jump quite as high, does it? And then we'll calculate it when we have a number of employees equaling 141 million plus 9 is 150. Going back to Desmos, we'll change this to 100 right here. And we get a GDP level of 15.309. Okay, then we're going to plot that point out here. So the 100 million effective laborers, we get 15.309. And we connect the dots with a curve, right? Notice the curve bends. We've only had two nonlinear functions in macro principles. The first was a PPF that bowed outward. Now we have the production function that rises more quickly when we go from no employees to a lot of employees, to rising very little when you go from a lot to many. We call this bend the law of diminishing marginal productivity. And what's going on here is you got to remember that capital is fixed. The number of factories are fixed. The number of production lines are fixed in the short run. So when you go from 0 employees to 50 million, you're adding a bunch of people to empty production lines. That causes production to go way up. When you add 50 more to that given production line, the production line gets a little crowded. And so people can't be, the last person hired here, the 100th million, can't be as productive as that 50th. And when you go from 100 to 150 million workers, production lines get even more crowded, right? Imagine a grill space where at Outback Steakhouse where you're making hamburgers. When you don't have any cooks on the grill, you're producing nothing. But if you had one cook, all of a sudden that cook can be really productive because they have all this room on the cook stove. But if you were to add, like, say, 10 cooks to that same cook surface, that 10th cook would probably have no place to flip a burger, and that 10th cook would not be very productive. So maybe that 10th cook sits outside and vapes or smokes a cigarette, right? They're not being productive at all. So the reason why this curve bows is because the production line gets increasingly crowded because capital is fixed in the short run. Okay, so since there are 9 million workers that are frictionally unemployed or are structurally unemployed, this, remember, is natural unemployment, right? And 135 million of the 144 million in the labor force are employed. We're going to compute the unemployment rate, the natural unemployment rate, the cyclical unemployment rate, the real GDP, and what we call potential GDP. So to calculate the natural unemployment rate, we take this 9 million workers who are frictionally or structurally unemployed. Those are the workers that maybe gave up a job to move out west because they want to live out west, and now they're looking for work, right? Or it could include the people who lost jobs as a result of automation, right? So this is the 9 million people who are structurally or frictionally unemployed. It's a healthy source of unemployment. We divide that by the labor force size, LF. So we have the natural unemployment level divided by the labor force, which is 6.25%. Okay? Now, potential GDP is, to calculate potential GDP, we're going to use the same short-run production function, only this time we're going to use the labor force instead of the effective number of laborers. Okay, so this is labor force. So YPLF, labor force, potential GDP. The labor force is 144 million people by assumption. The square root of 144 is 12. 12 times 1.25 is 144. Is 15. So if at the labor force size of 144, the economy's potential GDP is $15 trillion. Okay? Now, the unemployment rate is the size of the labor force. It's the size of the labor force, which in this case is 144. Size of labor force is 144 million. The number of employees, the number of people employed is 135. So this here is the number of people unemployed. This difference is the number of people unemployed. We divide that by the labor force and we get an unemployment rate of 6.25%. Okay. So the unemployment rate is equal to the natural rate, which means we're on our production possibility frontier. Unemployment's not too low. Unemployment's not too high. Unemployment's just right. So cyclical unemployment is just the difference between unemployment rate and the natural rate of unemployment. Here, cyclical unemployment is 0. Okay? So unemployment is just right because the unemployment rate equals the natural rate. Now, to calculate GDP, remember GDP is, the L here is the effective number of laborers. The employment number is 135 million, and the natural level of unemployment is 9 million. So when we add 135 to 99, we get 144. And the square root of 144 is 12. 12 times 1.25 is 15. So GDP is just right. See that? The effective number of laborers is 144 million. We're at the same point, and GDP is equal to potential. Okay, so this is a situation where policymakers want us to be. We're on the Bode production possibility frontier. Remember, the Bode production possibility frontier was a curve that looked like, where's my epic pin at? There it is. Here's my epic pin right here. I'm going to draw the PPF. Remember, the PPF looks like this. And this could be healthcare, which we'll define as H. And this could be all other goods, which we'll define as O. And we're on the PPF here. Okay, because the unemployment rate, whoops, I'll have to go back. Sorry, I had to go back one. Yeah, so the unemployment rate is 6.25%. The natural rate of unemployment is 6.25, so unemployment's just right. And then GDP is equal to potential. So we're at this point on the PPF. GDP is not too low, GDP is not too high. Unemployment's not too low, unemployment's not too high, it's just right. So unemployment and GDP are just right. We're on the PPF. Okay. Okay, in this situation, what happened? Suppose there's still 9 million workers who are frictionally or structurally unemployed, so the natural rate of unemployment does not change. And there's still 144 million people in the labor force. So these two things do not change. What has changed is the number of people who are employed that happen to be in the labor force. It went from 135 million to 112 million. See that? So the unemployment rate is going to change, and GDP is going to change. Cyclical or not, natural unemployment and potential GDP are not going to change. Okay? When people lose their jobs. So this is a situation where people lose their jobs. So this is the number of people in the labor force. This is potential GDP, and this point has not changed. Then the natural rate of unemployment hasn't changed, and the potential GDP has not changed. Okay, so what has changed here is that a bunch of people lost their jobs. And so the unemployment rate is now 22.22%, because this is the number of people who are employed, and that's the labor force. So unemployment went up when people lose their jobs. Cyclical unemployment is 15.97%. It's the difference between the unemployment rate and the natural rate of unemployment. So unemployment's too high. Now we're in a situation where we're out here. We're out here somewhere. Whoops. Oh, sorry. Oh, man, I got to redraw this. Dang it. Here's our PPF. This is maybe healthcare. And this is everything else, other goods, right? And initially we were right here on the PPF. In this situation, we're not on the PPF. We're inside the PPF. Unemployment is high, right? Unemployment is too high. So we're inside the PPF. Now to calculate GDP, we use the short production function, but we use the number of effective laborers. And here, the number of employed is 112. You add that to the 9 million who are frictionally or structurally unemployed, and you get 123 or 121 million. 121. The square root of 121 million is 11, and 11 times 1.25 is 13.75. So notice that GDP is lower. GDP fell because the number of employees fell, right? The number of employees fell. The number of naturally unemployed workers has not changed, right? So GDP is too low and unemployment is too high in this situation, right? GDP is lower than what it should be. All right? Okay. Okay, in the next situation, there are 140 million of the 144 who are employed. So here, employment has shot way up. We're holding the number of people who are frictionally or structurally unemployed constant. So the natural rate of unemployment has not changed. 144 million hasn't changed, so potential GDP hasn't changed. It's still 15. We're still here. But notice what happened to unemployment. There are a lot of people employed. A lot of people employed. And the unemployment rate fell to 2.78%. It is lower than the natural rate of unemployment, which means the economy is now out here. Okay? Unemployment is lower than the natural rate of unemployment. Cyclical unemployment is the difference in the two. So cyclical unemployment is negative 3.47. Unemployment is considered to be too low. And the reason why it's considered to be too low is because many economists believe that when unemployment is too low, it leads to inflation. And then the real GDP is found by plugging the number of people employed, in this case 140 million, and the number of people who are structurally or frictionally unemployed in there as well. 149 million, square root of 149 million, times the by 1.25 gives us 15.26. So now unemployment is too low. Whoops. Unemployment is too low. And GDP is higher than it should be if we were on the PPF. So we're out here, at a point out here. Okay? We're beyond the PPF. We're beyond potential GDP. Okay? Okay, so we're going to graph long-run aggregate supply. Long-run aggregate supply is the value of what GDP should be if the economy were fully employed, if all resources are being utilized at 100%. So the key here is, what is potential GDP? Potential GDP is 15. It's fixed in the short run. Why is potential GDP fixed in the short run? You got to remember the long-run production function was what? The long-run production function was technology and entrepreneurial talent times the square root of capital, resources, and the labor force. All of this stuff is fixed in the short run, right? All this stuff is fixed in the short run. And notice that there's no price level anywhere. If the price level is 0%, it has no effect on what these values are in the short run. Technology is still 1.25. The value of capital doesn't matter if the price level is high or low. Because we're talking about the real value of capital. We're talking about the real value of resources and land and the real value of our labor force. So it doesn't matter if the price level is high or low. Now, if the price level was in this model somehow, right, which it's not, then if it went up, then maybe these other things have to go down in order for this to remain at 15. But you don't see price level anywhere, so it's independent of price level. Price level is not in this long-run production function. So potential GDP is fixed in the short run at $15 trillion. And that's true if the price level is 10%, 20%, or 30%. So long-run production function is a straight up and down line at the value of what GDP should be if all resources are fully utilized. So going back to our production function, our PPF, if the economy is currently right here, with this being, say, healthcare, and this being other goods, all other goods, then the value of this point here is $15 trillion. And as long as the economy is on this point, GDP is equal to $15 trillion. It doesn't matter if the price level is 30, 20, or 10. It doesn't change the fact that we're on the PPF. Okay, now we're going to do the tutorial question 1 from tutorial 8. Okay, these numbers should look very familiar. The value of technology is 1.25. The value of capital is the same as what was in the notes, 2.5. The value of land and resources is 0.4. It's all given up here, right? So we're using the same numbers as we did in the notes. We multiply 2.5 times 0.4, we get 1. And the square root of 1 is 1. We multiply that by 1.25 and we get 1.25. Okay? Again, we have 9 million workers who are frictionally or structurally unemployed. That's why this doesn't change down here. We're going to increase the employment level from 1 million to 41 million to 91 million to 141 million and 191 million. When I add 9 and 1, I get 10. Okay, we're going to plug this 10 into here. Okay, eventually. Okay, before we do that, we're going to add 9 to 41, so we get 50. 9 to 91, so we get 100. 9 to 141, we get 150. And 9 plus 191, we get 200. Okay, now we're going to plug each one of these into that function. So we plug 10 in there and we get 3.953. We plug 50 in there and we get 8.839. We plug 100 in there and we get 12.50. We plug 150 into there and we get 15.309. We plug 200 in there and we get 17.678. Okay? So we did that on the notes, right? We did that in the notes. We added some values though. We only plotted 3 notes in the notes. We plotted three points in the notes. We're plotting 1, 2, 3, 4, 5 points in the homework, in the tutorial. Okay, here's our graph. There's our labor force, or the number of laborers, the effective number of laborers. This is real GDP. And at 10, we have GDP at 3.593. At 150, we have a GDP of 8.839. At 100 million effective laborers, we have a GDP of 12.5. At 150 million effective laborers, we have a GDP of 15.309. And at 200 million effective laborers, we have a GDP of 17.678. And again, notice the production function bends. And it's bending because our production lines are getting more and more congested, and it's harder to perform work. So you can't be as productive, right? Okay, then we're going to plug in the value of, here we suppose we have an employment level of 135 million workers, right? Compute the value of real GDP and the unemployment rate. Okay, the natural level of unemployment is 9 million, just like it was in the notes. We plugged the 135 in there, so 135 plus 9 is 144, and 144, the square root of that is 12, and 12 times 1.25 is 15. Okay? Then we got to calculate the unemployment rate, and remember the unemployment rate is the labor force minus the employment level. The labor force is up here. Labor force is 144 million people. So we're going to replace that with 144 million in both places. And the employment level is 135. And we get an unemployment rate of 6.25, just like we got in the notes. Okay? Now we want to compute the value of potential GDP and the natural rate of unemployment. So to calculate potential GDP, we plug in labor force instead of the effective number of laborers. And again, the labor force is 144 million people. So we get a GDP level of 15 because square root of 144 is 12. 12 times 1.25 is 15. To calculate the cyclical unemployment rate, we have to take the number of people who are structurally or frictionally unemployed, which is the level of natural unemployment, which is 9 by assumption. And we divide that by the size of labor force, and we get 6.25. Now the difference between real GDP and potential is 0. And the difference between unemployment and natural unemployment is 0 as well. Okay? So again, we're in a situation where we're on the PPF, right? We're on the PPF, where this is healthcare and this is all other goods, right? And we're on the PPF here. Because GDP equals potential and the unemployment rate equals the natural unemployment rate. All right, so GDP is just right and unemployment's just right. We're on the PPF. Okay, now we're going to graph long-run aggregate supply. Remember, long-run aggregate supply does not depend, if you remember from our production function, our long-run production function is technology and entrepreneurial spirit times the square root of R, K, and L. The price level is not in here, right? Here we're varying the price level, but you don't see price level anywhere here. You see technology and entrepreneurial spirit or talent, land and resources, physical capital, and the labor force. The price level is not here. Technology is fixed. Technology is fixed in the short run. It equals 1.25% of all the knowledge in the universe. Land and resources, the value of land and resources is fixed at $0.4 trillion. The value of capital is fixed at $2.5 trillion. And the labor force is fixed at 144 million workers. So these are all fixed. No matter what the price level does, it will not change potential GDP. Okay, so potential GDP was what? Potential GDP was $15 trillion. So all you do is you put that value into each one of these boxes. And so at this level at $15 trillion, with the price level at $0, we're here. At $15 trillion of real GDP, for $15 trillion in potential GDP, here the price level is $100. So you go up to this point here. At potential GDP equal $15 trillion, the price level is 1,000. at potential GDP equal $15 trillion, the price level is 10,000. So we're on a vertical line. Long-run aggregate supply is a vertical line, right? And if the economy is on this vertical line, then the economy is on this curve. Okay?